Close your eyes.
This world is not what you think it is. This world is not what you think it is.
Is that called scientism, when you believe so much in the science you've been taught that you refuse to believe something else and it becomes your religion in a way?
Yes, scientism is where people turn science into a kind of religion. It becomes a kind of dogmatic belief system. The irony is that a lot of people think that religion is dogmatic and science is free thinking, but actually, in my experience, some of the most dogmatic people I know are people who've made science into a kind of religion.
We still have flat earthers. We have people that don't believe in vaccinations. And what do we do about it? Well, first of all, I think there's a gene. I think there's a gene for superstition, a gene for hearsay, a gene for magic, a gene for magical thinking. And I think that when we were in the forest, that gene actually helped us. Because 9 times out of 10, that gene was wrong. Superstition didn't work. But 1 time out of 10, it saved your butt. That's why the gene is still here. The gene for superstition and magic. Now, there's no gene for science. Science is based on things that are reproducible, testable. It's a long process, the scientific method. It's not part of our natural thinking. It's an acquired taste. It's like broccoli. You have to learn how the power can be unleashed by looking at your diet, for example. So I think 1,000 years from now, we will have flat earthers.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros. This is the largest mismatch between theory and experiment in the history of science.
The cult of scientism. And it is a cult that plagues society. And we saw this firsthand the last 3 years. It was on full display. So I think the thumbnail is very fitting. You have a dude in a white lab coat, and then all the sheep are just following whatever he says. That's pretty much how the world works now. And I think that the overarching part of it that's super funny to me is, say you are one of those people who believe in everything the current scientific consensus claims. And there are many of them. The most ironic part is, even within that paradigm, everything that the scientific consensus used to think is now considered wrong. So those same people would have been around like promoting the consensus at the time, even though it was wrong, and they would have been mocking and ridiculing those who dare question it. And this is frankly, the weak, less intelligent, easy way out, is to just appeal to the idea of consensus or scientists and call other people science deniers or mock or ridicule anyone that dares question something that you think is definitively established as science. It's pretty funny. I can give you plenty of examples. Let's say people believe that this fuzzy hair crackpot, the one that said this, well, when I was a student, I came across experiments of this kind, or I found out that experiments of this kind had already been made, in particular by your compatriot Michelson. He proved that one does not notice anything on Earth that it moves, but that everything takes place on Earth as if the Earth is in a state of rest. Albert Einstein, and of course, a lot of people believe in his theory of relativity, the special and general theory. And if you were to just say, let's just say hypothetically his theory is correct, it's provably not correct. It's laughable that people actually think it is. It's only people that don't know anything about it. There are levels to this, right? There are levels to the cult of scientism. There are those drowning in it. But, mainstream top tier academics know that relativity is wrong. Best case scenario, drastically incomplete. doesn't work. It's paradoxical. It's contradictory. It's just in complete best case doesn't work on the cosmological or quantum scale. Saying that it works on the local scale doesn't mean anything. Like, I can give you 5,000 theories that work on the local scale. We just see phenomena that's reoccurring, and then we can apply a theory to that mathematically. That's not even impressive. It's actually shouldn't even be mentioned. It's that stupid. It's like, why? It literally shouldn't be mentioned as to the validity or veracity of a theory. But anyway, I digress. Let's just say that Einstein is correct in his theory that claims concepts can bend. So, before Einstein, everyone believed in Newtonian physics. They believed in an ether with an absolute frame of reference and Newtonian physics. All physicists, quote unquote, right? That was the consensus across the board. And if you were dared to question ether, for example, you would have been laughed out of the room. Like, well, what sustains electromagnetic waves and light waves? And this is the foundation for all electrical field theory. The idea that someone would even utter the idea that an ether doesn't exist is stupid. There has to be a background medium sustaining the electromagnetic energy and propagation. We all know this. Everyone knows this. Every theory we've ever come up with about electrical field theory requires it, integrates it, assumes it, applies it. It's the only way we made any progress. How would anyone dare think that there is no ether or that Newtonian physics was wrong? Everyone thought this. And of course, everyone also understood that according to Newton himself, if his physics was correct, which he didn't even apply a mechanism or offer one, it required an ether. And he went in detail about what the ether was and his idea, and that was omitted conveniently because it is a cult. A cult will give you selective information so that they can guide you to believe a certain thing. All these people that say, like, oh, Newtonian mechanics works good enough, blah, 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 or they think that Newton is such a genius. Well, they omitted the fact that Newton actually said there has to be an ether and that this must be a direct act of God. What he called gravity is there's no other way, didn't offer a mechanism, left it up to the consideration of the readers, blah, blah, blah. Long story short, Einstein got laughed out of the Royal Society whenever he invoked the idea of the bending and warping of space-time and the relativity theory. People thought he was insane. And a lot of these people that you see that have become genetically modified and jabbed themselves up and still brag about it to this day, or want to jab children and fell for all the pseudoscience. Oh, wear 17 masks, never mind 0, never mind, make it 3. Those people that are still scared of the air, the people that don't know how to think outside of what CNN or Fox News tells them, the people that can only read popular science headlines and think that makes them smart if they can regurgitate it. Those same people would have ridiculed Einstein because all the scientists at the time said that Newtonian physics was true and there was an ether. So in their own paradigm, that type of thinking, that approach doesn't work, provably so. Throughout all of history, the current scientific consensus has been wrong about everything. You can't name an exception. Everything. All things. Everything. Okay? So in fact, the only thing you can be sure of is that the current scientific consensus about everything is wrong and it's incomplete. That's reality. And sure, we may have understandings that may not change, that we've even definitively proven in terms of scientifically. Although nothing can be fully proven, we don't know all variables. That's why it's automatically wrong. We can only come up to a conclusion based on what we do know at the time. Okay? And it's funny. It's just funny. People do it every time. And frankly, I know why. It's the easy way out. It's the intellectually lazy and frankly, not to sound ugly, but incompetent way out. If you don't have to think for yourself, it's easier. The weak conform to consensus, like I always say. I always say that. I coined that phrase because it's very true. Weak find contentment in the consensus of ignorance. And it's a very real phrase. It's very accurate. Weak-minded people, incapable of individual thought or assessment, they will just conform to what they think the majority says. And oftentimes you will find they do not know what it says. This is why people ridicule you for saying that the earth is a plane, but they do not know anything about the globe model. They don't know why they believe it. They don't know how they allegedly verified any of these claims. They don't even know what it is. They don't know what it claims to be in the first place. They just know everyone says that it is the case. Apparently science has proven it. They can Google it and says that it was proven 2,000 years ago. So if everyone thinks that, then I'm in a safe position to ridicule anyone that dares question it. And now that's my safe space. Okay? That's what people do. That's what people always do. And again, what proved this more than anything was the last 3 years where people were walking around scared of the air. Like, scared of the air, not scared of the air. Oh, I'm scared of the air again. Oh, make it 3 masks, blah, blah, blah. Whatever the TV was telling them, whatever the illusion of science was telling them, and then they would call you a science denier. Back in the day, they would have said, Einstein's a science denier, which actually would have been accurate, ironic. They would have said anyone that dares question Newtonian physics and the ether is a science denier. They're an idiot. You're stupid. We know that there is an ether. We know that Newtonian physics is correct. Anyone that dares question it is insane. They would have mocked him and ridiculed him because that was a consensus at the time. And that just goes to make my point, which is that the people that do that, they would have been wrong throughout all of history in their own paradigm. Like everyone that works within any realm of physics at the higher end at all, they know that Einstein's theory is wrong. That's why you only see anti-flat earthers on the internet defending relativity as if it is a fact. People know it's not. We know, in many ways, that it's wrong. But people will cling on to it. There's a famous quote, I forgot who said it, but it's very difficult to get someone to understand something whose profession requires them not understand it. And that's why we are always so far behind the actual knowledge, meaning relativity's already been disproven. But there hasn't been an agreed upon replacement. So they just keep using it, claiming it's true, and then it trickles down to the masses, and the masses think it's still accurate. They know it's inaccurate. They know that. And it'll be 20 years at least before they come out and officially change the consensus stance. And then these people will update their worldview. Just like whenever they came out and said, oh, we discovered Polaris is actually over 100 light years closer than we thought. Oops, we were off by 30%. Of course, a light year is 5.88 trillion miles. This is a 30% error. It's not pretty insignificant. Overnight, these people updated their worldview. It's easier to hand your thinking over to other people. For one, it requires less time and effort. And for two, it comes with less responsibility. Oh, the science got it wrong. Oh, that's how science works. We're trying to figure stuff out. We. You'll hear this inclusive pronoun of we. You didn't do anything. We have a model. You don't have anything. Our model. You don't have a model. You know, like, oh, science does this. We figured things out. No, first of all, science isn't a group, isn't a thing of people. It isn't a person. Okay, science isn't sentient. We, but they do nothing. Like, oh, where's your model? The Earth isn't a model, nor is any human in possession of that. You know, it's the Earth, and you don't have a model. Okay, so this is just, it's intellectually incompetent and weak position and an intellectually lazy position to take. Just to really drive this point home, right? What you're going to see, and people still doing the very thing that I'm elucidating, that I'm describing right now. They're going, like, if you say the electron's not real, they'll call you stupid. But the truth is, they don't know who discovered it. They don't know the physical properties of it. They don't know the progression of it. They don't know the understanding. They don't know the contradictions. They don't know that it's allegedly a point particle with no size or shape, but still it's 100 million times smaller than the atom, allegedly, but we can't ever tell exactly where it is. And it's a mass. It's literally a particle of matter, but it has no size or shape, right? It's like they don't know that. They just know that they can say, you're such an idiot. You don't believe in the electron. How does your computer work? It's just low. I'm trying not to be too derogatory, but it's like low IQ nonsense. It's gaslighting. It's all fluff. Okay. So you can just rest assured, like, who cares what those people think? They're the loudest people in the room, but they're the least relevant in terms of like actual progression of intellectualism and science. So there you go. That's what the danger of the cult of scientism is, that it creates slaves. It creates mob mentality people that don't think for themselves, don't know how to individually access information, are terrified of ever going against the majority or societal ostracism. And so you have a very useful tool to control people by using the word science, deifying the idea of people in lab coats. Now, I've talked to quite a few scientists. You find out they don't even know what they believe. They don't know any of this. I just talked to a PhD astronomer the other day, and I'm like, what about the redshift anomalies? And he only knew of one of the 5 I named off the top of my head. He does that for a living. He didn't know about all the redshift anomalies. If their redshift assumption is incorrect, everything they think they know about space is incorrect. It's all built upon the redshift interpretation. That's just an example. It's a facade. It's a facade. Just like in a cult, everyone thinks that the leader has some secret, sacred information, but in fact, it's a facade. Okay? And the people outside the cult can see. And basically, we used to be in the cult because we're indoctrinated into the cult at a young age. We got out of the cult. We're just like, bro, you're in a cult. Just get out. And they try to call flat earth a cult, projection. They try to call flat earth stupid, projection. Say they don't have physical evidence for flat earth, projection. That they can't verify flat earth, projection. They don't have physical measurements of flat earth, projection. Everything they say is a direct projection. Oh, you just believe what other people say, projection. Oh, you just do this to make yourself feel special, projection. It's all projection. There's something in the universe about when you lie, you're forced to project.
A science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. This is a very widespread belief in our society. It's the kind of belief system of people who say, I don't believe in God, I believe in science. It's a belief system which has now been spread to the entire world. But there's a conflict in the heart of science between science as a method of inquiry based on reason, evidence, hypothesis, and collective investigation, and science as a belief system or a worldview. And unfortunately, the worldview aspect of science has come to inhibit and constrict the free inquiry, which is the very lifeblood of the scientific endeavor. Since the late 19th century, science has been conducted under the aspect of a belief system or worldview, which is essentially that of materialism, philosophical materialism. And these sciences are now wholly owned subsidiaries of the materialist worldview.
Several decades ago, we found a problem so great that it was brushed under the carpet for many a decade. And this is the fact that galaxies spin too fast. We believe in the work of Isaac Newton, at least on planetary scales, but when you apply Newton's laws of motion to the galaxy spins too fast. In fact, 10 times too fast. By rights, the galaxy should fly apart. Therefore, scientists said that we have to have dark matter, a halo of matter that surrounds the galaxy and holds the galaxy together.
Between 1 and 3% of the universe is all the stuff we can see, and somewhere between 99 and 97% of the universe is stuff we can't see. This dark matter that dominates our galaxy, we're virtually certain now, is made of some new type of elementary particle, different than the stuff that makes you and I up.
And what have they discovered? Absolutely nothing. Zilch.
What is a little bit perturbing is that after 50 years we still haven't found what the dark matter is. But on the other hand, that doesn't mean they're not there, it just means they're harder to find than we thought.
We look out in the universe and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really we should be calling it the dark force, because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is just simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. We've known about dark matter since the 1930s. Back then it was called missing mass. That's what it was called. Because, there's got to be some mass. Where is it? We can't find it. It's got to be here somewhere, because we got the gravity. If you have the gravity, you got to have the mass. Mass and gravity go together. It's really dark gravity. Actually, we shouldn't call it anything. We should call it Fred. Something that has no meaning, because we don't know what it is to call it. But it is the longest standing unsolved problem in modern astrophysics. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, to try to explain the data, such as inflation, dark matter, dark energy, and so on, just to keep patching the theory up.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros. This is the largest mismatch between theory and experiment in the history of science.
Physicists who make up the laws of nature are less constrained by them than most of us. And in the 1980s, people who were studying galaxies found that the galaxies weren't behaving as they ought to. These stars in the galaxies were revolving around the center far too fast, according to the amount of matter there should be in the galaxy. And galaxies were attracting each other too strongly to be explained in terms of the total amount of matter within them. If you add up all the matter within them, stars, planets, gas clouds, make generous assumptions for invisible stars and so on, there's not enough matter to explain the gravitational pull of one galaxy on another, or of a galaxy on its outlying stars. So there was a terrible dilemma. What to do? Either the theories on which cosmology were based, Newtonian or Einsteinian relativity and gravitation, were wrong, or there was some organizing principle in galaxies over and above gravity that scientists had missed out. Or there must be a lot more mass that we couldn't see within the galaxies that could explain the missing gravitational effect. Well, the least disruptive assumption for scientists was that there was a lot more matter that we couldn't see, and because we can't see it, it was called dark matter. So they postulated that there was dark matter in the galaxies that would explain these phenomena. The distribution of dark matter could be adjusted for each galaxy to explain its shape and its behavior. How much dark matter did each one have? Well, the answer is simple. You just titrate in as much dark matter as you need to make the equations balance and explain the form of the galaxy. And that's the prevailing view. There are still minorities in science who think that there have to be other ways of thinking of galaxies or modifying gravitational theory, but the great majority take the view that dark matter is real. However, the problem with that is that there's not a shred of evidence for its existence. Despite billions of dollars being spent on dark matter detectors, underground pits full of fluids and so on, not a shred of evidence has emerged that it actually exists. The only evidence for it is that it makes the equations balance and enables the conventional theories of physics to survive any test, because you can add in more dark matter or subtract it as required to explain what you want to explain. It's basically an untestable theory. They've tried to test it, the tests have failed, but nobody's given up the theory because it fits the theories that they want to believe in. Now, this led to a serious problem, because having magnified the amount of energy in the universe by about 5-fold through dark matter, there's far more of it than regular matter, that meant the whole universe had far more gravitation than people had previously thought. And that would mean that the expansion of the universe, following the Big Bang, the expansion that's still going on, should be slowing down owing to all this extra matter within the universe. And in the 1990s, people thought that the universe would stop expanding, it would finally reach an ultimate limit, and then be pulled back together by all this matter in the universe gravitationally, until the whole thing ended in the opposite of the Big Bang, known in the trade as the Big Crunch. And the whole thing would end in tears. Well, that was the general view in the 1990s. But about 1999, observations of distant galaxies revealed that far from slowing down in their recession from us, they were speeding up. The universe was expanding faster and faster all the time. The exact opposite of the prediction of the dark matter theory. So, what to do? Well, again, you can't modify the fundamental assumptions because they're fixed. So, they did modify it in the sense that they said, well, there must be an extra form of energy pushing the universe apart. And we'll call that dark energy. And it's dark energy because it's undetectable by anything other than its effects, namely pushing the universe apart faster and faster. The problem is, this has now led to a tremendous problem for the principle of conservation of matter and energy, because the main theory of dark energy is that the density of dark energy is uniform throughout the universe and remains uniform. But since the universe is getting bigger, that means there must be more of it. So the universe is now a perpetual motion machine. It's actually creating energy as it expands. So, is the law of conservation of matter and energy valid? Physicists have made up matter and energy in the last 20 or 30 years till the made up matter and energy, dark matter and energy, is now 95% of reality. Can it be converted into regular matter? Could some matter suddenly appear in this room as a result of being transformed from dark matter or dark energy? Well, nobody knows, because no one knows anything about dark matter and dark energy. So we're left with this it's as if physics has discovered the cosmic unconscious. 95% of reality is utterly unknown to us, and yet it's pervading this room.
What you'll see is people be like, where's your science paper? Where's your published paper? And I have a published paper, a peer-reviewed paper, about how peer review sucks. Literally. A peer-reviewed paper, how 60 to 70% of peer review is complete garbage, and that they contradict themselves and all kinds of stuff. A peer-reviewed paper says your peer review is stupid. Oh, the scientists looked at it. No, a bunch of people with highlighters looked at it. That doesn't mean anything. No one cares. Like, oh, this isn't the agreed upon thing. We can't cover that. We can't allow it to be published. Who cares? It's stupid. All I'm trying to do is encourage the people that are victim to that, to the people that ostracize you. Just like stand tall and just disregard them. Frankly, treat them as children. Like, the children don't know any better. They just like, they're going to scream and call you names, but like, don't take the bait, right? It's just a child. It's like, okay, little Timmy, it's okay. Eat your lollipop. It's like literally how you should look at it, because these people, I've come across thousands of them at this point. It's just a joke. They just say things. They gaslight you. They blatantly project. They twist, manipulate. They psychologically manipulate everything that they're saying to you to try to make you internalize their defamatory remarks, etc. It's just very toxic, hateful, atheistic, nihilistic, low IQ nonsense. You can disregard it, treat them as children.
Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop, because they're given with errors of any fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. Then in 1945, it went up, 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it, so I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants. And I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking. So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we've defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem. But I said, well, then what about big G, the gravitational constant known in the trade as big G? It's written with a capital G, Newton's universal gravitational constant. That's varied by more than 1.3% in recent years. And it seems to vary from place to place and from time to time. And he said, oh, well, those are just errors. And unfortunately, there are quite big errors with big G. So I said, well, what if it's really changing? I mean, perhaps it is really changing. And then I looked at how they do it. What happens is they measure it in different labs. They get different values on different days, and then they average them. And then other labs around the world do the same, and they come out usually with a rather different average. And then the International Committee on Metrology meets every 10 years or so and average the ones from labs around the world to come up with the value of big G. But what if G were actually fluctuating? What if it changed? There's already evidence, actually, that it changes throughout the day and throughout the year. What if the Earth, as it moves through the galactic environment, went through patches of dark matter or other environmental factors that could alter it? Maybe they all change together. What if these errors are going up together and down together? For more than 10 years, I've been trying to persuade metrologists to look at the raw data. In fact, I'm now trying to persuade them to put it online on the internet with the dates and the actual measurements and see if they're correlated, to see if they're all up at one time, all down at another. If so, they might be fluctuating together, and that would tell us something very, very interesting. But no one has done this. They haven't done it because G is a constant. There's no point looking for changes. You see, here's a very simple example of where a dogmatic assumption actually inhibits inquiry. I myself think that the constants may vary quite considerably, within narrow limits, but they may all be varying. And I think the day will come when scientific journals like Nature have a weekly report on the constants, like stock market reports in newspapers. You know, this week big G was slightly up, the charge on the electron was down, the speed of light held steady, and so on. That's one area, just one area where I think thinking less dogmatically could open things up.
Peer review. This is a peer-reviewed paper. Journal of the Royal Society of Medicine, a flawed process at the heart of science and journals. Okay, peer-reviewed, a flawed process. It's over here. It's hilarious. I should just bring this up in all my debates. Peer review is at the heart of the processes of not just medical journals, but of all science. It is the method by which grants are allocated, papers published, academics promoted, and Nobel Prize won. Yet it is hard to define. It has until recently been unstudied. Wow. So peer review is antithetical to the very, premise people invoke it to defend. And its defects are easier to identify than its attributes. Yet it shows no sign of going away. Famously, it is compared with democracy, a system full of problems, but the least worst we have. And you guys can read through it. Come down here to the conclusion, which you should read articles, not just go to conclusion. That's what ballers do. But anyway, so peer reviewed is a flawed process full of easily identified defects with little evidence that it works. Nevertheless, it is likely to remain central to science and journals because there is no obvious alternative, and scientists and editors have a continuing belief in peer review. A what? A belief. Like a religion or a cult? How odd that science should be rooted in belief. I'm telling you, it's almost like it's a religion, and it's actually not science, it's scientism, huh? So here's your peer review. You guys want your peer review paper so bad. Here's a peer review paper telling you that your peer review process that you rely on and invoke as if your pantheon is actually built upon belief, and it's basically dogmatic religion. And if you're not inside the cult upon agreed upon ideas, then you're not going to make it through the process. No.
The idea was to hang by a very, very fine quartz fiber a rod with two balls, and then put two large lead balls in the positions indicated here next to it on the side. Then, because of the attraction of the balls, there would be a slight twist to the fiber. It had to be done so delicately because the gravitational force between ordinary things is very, very tiny indeed. And there it was. And it was possible then to measure the force between these two balls. Cavendish called his experiment weighing the Earth. We're pedantic and careful Today, we wouldn't let our students say that. We would have to say they're measuring the mass of the Earth. You know? But the reason he said that is the following. By a direct experiment, he was able to measure the force and the two masses and the distance and thus determine the gravitational constant. You say, yes, but we have the same situation on the Earth. We know what the pull is, and we know what the mass of the object pulled is, and we know how far away we are, but we don't know either the mass of the Earth or the constant, but only the combination. So by measuring the constant and knowing the facts about the pull of the Earth, the mass of the Earth could be determined. So indirectly, this experiment was the first determination of how heavy or how massive is the ball on which we stand. It's a kind of an amazing achievement to find that out, and I think that's why Cavendish named his experiment that way instead of determining the constant in the gravitational equation, weighing the Earth. Oh. He incidentally was weighing the sun and everything else at the same time, because the pull of the sun is known in the same manner.
Bueno.
En los naranjos.
Bueno, yo me entiendo. Jesús me mandó el cocinero por la noche a las 2 de la noche.
Pero te conviene que te entienda alguien más porque para eso cobras.
Ah, bueno, que está arriba. La sa del agua de la playa.
Abajo, los espectadores.
Espectadores, la sa que te echa a la playa.
Eso es.
No es lo de Semana Santa que es los naranjos. Y Risita, coge las 20 paelleras, las amarra y las entierra en el agua. Y acuérdate, a donde las echa, que mañana tienes que ir a por ellas. Y cuando salgo, era a las 2 de la noche, había bajado la marea. La dejé amarrar, tal como me lo dijo, las tiré, le puse un palo. Dice, llego a la cocina, eran las 2:30 de la noche. Risita, ¿qué la has hecho? Allí ya está, jefe. Ya, pues acuéstate, que mañana a las 8 te llamo para que vaya a recoger las paelleras. Y me acuesto en su, ya para abrir el restaurante que era el arroz. Y me llama el cocinero. Risita, ¿qué? Ve por la paellera. Venga, que a las 2 de la tarde ya están aquí. Miren, bañador, en las chanclas. Todo despeinado porque no me dio tiempo nada ponerme las chanclas y el bañador. Voy a la playa, había subido la marea. Jesús. Jesús. Había subido la marea y encontré una paella. Y la encontré porque estaba la paellera agarrada metida entre las piedras de Chipiona, del faro. Y cuando entro en el restaurante me ve el cocinero con una paellera y adentro la 20 paelleras. ¡Asómate, mira dónde llega el agua! Llegaba el agua hasta el restaurante. Había subido la marea. Jesús, hay que hacer ahora con los 2 sacos de arroz. ¡Ay, llama para Sevilla! ¡Llama a Sevilla que traigo ¡ay! Jesús, yo con el bañador y con la paella. ¡Ay, el cocinero! No vea, para Sevilla. Y al último, que cuando ya salió la bien de regla, estamos llorando los dos. Me cobró el tío la paella. Me cobró a 500 metros la paella. Y ya no fui más. Me fui andando a coger los amarillos hasta hoy. Me mandó por la noche, había bajado más el agua y por la mañana había subido. Cualquiera estaba donde está la paellera, ¿sabes? A lo mejor está en el barco ese del petróleo.
En el Prestige.
En el Prestige ese. Y ya no otra más la cocina. Ya aburrí sin la cocina. ¡Ay! 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 Pues no cobré nada, me dieron el dinero del bote.
¿Había mucho dinero en el bote?
Lo que me echaban y el dinero de lo que gané, me cobraron 20 paelleras a 500 calas, pues viste lo que me llevé yo para Sevilla. Ay, ya aborrecí la playa. Hemos llorado los dos. Ya está, tú, no es para tanto, yo. A ti yo no quiero arroz, Jesús, yo no quiero arroz ni en chino, vamos.
Is that called sciencism when you believe so much in the science you've been taught that you refuse to believe something else and it becomes your religion in a way?
Yes, scientism is where people turn science into a kind of religion. It becomes a kind of dogmatic belief system. The irony is that a lot of people think that religion's dogmatic and science is free thinking. But actually, in my experience, some of the most dogmatic people I know are people who've made science into a kind of religion. As my friend Terence McKenna used to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. And the one free miracle is the appearance of all the matter and energy in the universe and all the laws that govern it from nothing in a single instant.